All right, now I kind of briefly showed you this last week, but okay, in terms of what we're doing with the Properties of Compounds lab, okay, in Google Classroom, because of the changes to Google Classroom, assignments don't look the same in the stream as they did last year. Last year you could see all the details in the stream, but they've compressed it for some reason. Okay, so if you click on the thing here where it says I've posted a new assignment, Properties of Compounds lab, okay, if you just click on that, it will take you to the detailed version of that. Now, right now there's not much in there because obviously right now I'm recording the instructions for it. Okay, I will post them in there later. Okay, what you'll see in here is a PDF document. That PDF document is the lab sheet itself. Okay, I don't print that for you because you can access it here. Okay, and I'll be working off of that as I explain things to you for the lab today. Okay, and then there's the Google Doc here that has your name on it, not mine. Okay, so when you open up yours, it has your name here and says U1 Properties of Compounds Lab Report. That's the one you need open, okay, because that is the one you will be handing into me. Okay, and you'll be handing it in electronically through Google Classroom with the turn-in button. Right? I am not accepting paper of any kind for this. Okay, this comes in electronically only. All right, so you can see here that this is set up very much like what we talked about on Friday. Okay, the lab report format is set up here. Okay, this is the template for you. You're going to fill it in. Okay, so I've already got the problem here and reminding you that you need to restate the problem in your own words as a question. Okay, and then there's room here for you to identify and explain all of the variables. Okay, and you're reminded here to explain your choices. Okay, we'll go through that in a minute. Your hypothesis, you're reminded here, it needs to have if, and then in it. We'll go through that in a minute as well. Okay, and then there are the materials. Now, the important thing about the materials is that all the identities of the unknown compounds are here. All right, because the purpose of this lab is that you'll be able to take all the unknown compounds that'll be on the front table tomorrow and assign them an identity from that list. Okay, because all you'll see is a beaker labeled A, B, C, D, whatever. Okay, and you'll have to be able by the end to tell me down here, okay, that compound A is sodium chloride or compound B is water or whatever it works out to be. Everybody follow me on that? Okay, so all of the possible identities are here in the material. So one of them is ammonium nitrate. Okay, we talked about that last week. We said that's the one that's in those cold packs where you pop the bubble. Okay, paraffin, that's candle wax. Okay, hydrogen chloride, hydrochloric acid. Okay, cobalt 2 chloride. Okay, ionic compound containing cobalt and chloride. Distilled water. Okay, copper 2 sulfate. Okay, sodium chloride, sucrose, which is table sugar. Okay, nickel 2 chloride, so ionic compound containing nickel and chlorine. Ethanol, okay, which is alcohol. Sodium hydroxide, okay, NaOH, and then obviously, I don't know why water's on there twice. That's a mistake. There's not two ones in there that are water. All right. Everybody with me on that? Now, there's a few other pieces of material in there, and I'll get to those. In fact, I'll bring them in and show them to you as we're going over what the procedure is going to look like later on in class today. Okay, questions so far? All right, so you guys will want to have that open while I'm walking through the rest of it. Okay, so you can fill in some stuff, type in some stuff. Okay, you may not have time to type in exactly what you want in full detail right now. You might want to just, excuse me. You might just want to put notes in the margins or just put a note in here. I want to talk about this in this part or something like that because you probably won't get time to do everything quite like you would like, or you might get a little behind. Okay. All right, so this is what the lab sheet, that PDF document, looks like. Same format, it's just got the information in it. Okay. So the problem that I have written here is obviously going to need to be reworded by you. Okay. So the problem we're investigating is if we're given a bunch of unknown samples, how can we classify them as ionic, molecular, acids, and bases, and use that to determine their identity. Okay, so you need to find some way to restate that in the form of a question. Essentially what we're trying to do here is identify some unknown compounds. That's our problem. We have unknown compounds and we need to identify them. Okay, so you need to find a way to write that as a question. Okay, now, last week we talked about the different kinds of variables. Okay, remembering that the manipulated variable is the thing that the experimenter is changing, okay, throughout the lab or doing differently throughout the lab. The responding variable is the variable or variables that are changing as a result of what the experimenter has done. And the controlled variables, and you will list 3 of them, okay, are things that need to be kept the same every time the experiment is run or a new trial is run or whatever. Okay, so this lab's going to work like this. You're going to have unknown compounds labeled A through K. You'll have them on a spot plate, okay, or a depression plate. I'll show you what that looks like in a little bit. And you're going to run the same set of tests on every one of those unknown samples. Okay, those tests we talked about last week. One will be the observable properties, where you record things like color and texture and all that kind of stuff. Okay, one will be a solubility test, one will be a conductivity test, and then lastly, a pH test. Okay, those are the tests. You're going to run those same tests, okay, in exactly the same way on every unknown compound. Okay, so essentially, it's like you're doing the procedure like 10 times. Okay, but each time you do it, it's going to be on something different. Okay, on some new ionic compound or unknown compound. It could be ionic, it could be molecular. Okay, so each time I run this experiment, what am I doing different? Yeah, we're going to talk about it. We're not even there yet. Okay, so as the experimenter, each time I go into this experiment, what am I changing? Right. Each time I do this experiment, I'm doing it on a new material. Okay? I mean, this is all kind of one experiment, but I'm testing each material in exactly the same way. Right? So does that mean that could be our manipulated variable? I'm really going to spoon feed you this first lab. Don't expect it like this every time. Okay, but this is your first high school lab, so here you go, open wide. Okay, okay. I'm going to spoon feed you. Okay, on this one. So our manipulated variable here is the unknown substances. Okay, you need to explain why. Okay, and we kind of already said that. So if you listen to this while you're doing your lab report, you'll probably get it. Or if you were listening closely right now, which is even better. Okay. Since each time I run this test or these tests, I'm running them on something different, what's my responding variable going to be? Yeah. Okay. I mean, if I test something different, but I test everything the same way, the results of those tests had better be different. If they're not, the whole premise of this experiment is faulty. Okay. I mean, if I test 10 different things and I get exactly the same result for every single one of them, I either tested the same thing 10 times or nothing has its own physical properties, which would really mess with how we understand matter works. Okay. All right, so our responding variable needs to be the results of the tests, okay, or the physical properties of the materials, okay, would probably be a more specific way to say that, okay, and again, you need to explain why. Okay, we need 3 controlled variables, so we need to think of things. We're running, we know what tests we're running, okay, what are some things that we should do the same each time we run the test, or should stay the same throughout the experiment?
The order you choose, like the order you test, you use the order of the test you use for each substance.
Yes, exactly. You should do all the tests for each substance in the same order. Okay? Otherwise, that could affect the results. That's a great control variable. And you should have the same amount of the unknown substances. Absolutely. Okay? I'm going to let you guys come up with a third one. All right? Each of you might have something different now, but yeah, we've come up with 2 out of 3 there. Okay? Things to think about for that third one could be environmental. Okay? Things that could affect the tests that might be environmental in nature. Be more specific than that. Don't write things that are environmental in nature as your control variable. Okay, come up with a specific environmental thing. Okay, remember when you do those explanations, okay, for the controlled variables, you need to say, here, this is a controlled variable. this is why it's being controlled, or sorry, this is how it's being controlled, and then this is why it's being controlled. Okay, the why part can be this is how it would affect the experiment were it not controlled. Okay, so controlling it, like the one we had there was different amounts of materials. Okay, well, we want to have we want to have the same amount of each material. Okay, why is that important? Well, some of the tests, I mean, if I had way more of one thing, it might look like it doesn't dissolve in the solubility test, and I had like 2 grains of this other thing, and it dissolved right away. It's not really a fair comparison. Okay, things like that. Okay, so this is how it would affect the experiment. I'm controlling it by making sure I measure it out or whatever. Okay, for our hypothesis. Okay, if, and then. This experiment only works if all materials have their own distinct physical properties. Okay, this experiment only works. Okay, we only get the results we want if that's true. Okay, so I've kind of just given you the if part there if you're really paying close attention. Okay. The and part of the experiment needs to just, or the and part, sorry, of the hypothesis needs to describe the experiment, right? So don't go into too much detail. I don't want this to be a paragraph long, okay? You can just say something like various physical properties of unknown substances will be determined, okay, or something like that. It doesn't have to be super specific. It is a very general, basic description of what you're going to test. Okay, the then part needs to tell people what is going to happen. Okay, so we've already said that if everything has its own unique physical properties and we run these tests, then, okay, what are you going to see as results? Okay, and what are you going to be able to do with them? Right? The whole purpose of this is to identify unknown compounds. Okay, but we're only going to be able to do that if we get this data. So you need to talk about what you're going to see as results in general. Okay, you got a bunch of different substances we're hoping will react differently. Okay, what are you going to be able to do with that? Okay, questions so far? Everybody all right with that? Okay, I'm going to give you a few minutes because I know you've probably written some stuff down but would like to make a little bit more detail in what you have typed there. I'm going to give you a couple minutes to do that while I go grab some of the equipment we're going to use so that you can see what it looks like. Okay, so I'll give you guys a couple minutes while I grab that stuff. All right, so the next thing that you and your group are going to have to put together, okay, is the procedure. Okay, that needs to be a very detailed step-by-step set of instructions. Okay, made so specific and so explicit that like my 8-year-old could follow it and successfully perform the experiment. And he's pretty scientific, okay, but like he's 8. Okay, so you have to make sure that this is written right out. You got to tell the person who's reading your procedure, here's what you do, here's where you get stuff, here's the observations you need to make, here's the order in which this test has to be run. Like if we're talking about a solubility test, for example, okay, we said that part of the solubility test is also checking to see if there's any temperature change when the water is added. Okay, so that means that when you're explaining how to do the solubility test, you don't write perform solubility test. Okay, that's not very specific. Somebody's not really going to know what to do there. Okay, so you would say, okay, with the thermometer in the unknown sample, record the initial temperature. Okay, then add water slowly. Okay, until the the depression is however full. Okay, recording the temperature while this is going on and gently agitating. You have to be that specific. Okay, you're telling them here's what you do, here's how you do it, and here's what to watch for. Okay, so you'd be telling them watch for any changes in temperature and look for any changes in the material. Okay, is it shrinking? Is the solution changing color? These are the things to record. That's how detailed you need to be when you're explaining to somebody how to perform a very simple test. All right, everyone kind of follow me there? All right, so we're going to quickly review here what the tests are that you need to run. All right, the first one is going to be the observable properties test. So when you get to the lab, okay, tomorrow, first thing you'll do is put on safety goggles. Right? Those can be found in the drawers of every lab station. Okay? We have many ones that are at least moderately stylish and will not leave marks on your face. When those run out, and I say when, okay, because they always go first, we have some very non-stylish but far superior in the protection department safety goggles with like the elastic bands on them that are, you know, huge and leave mark on your face. Right? But okay, they are all going to sufficiently protect you for our purposes. Okay, so you put those on. If you want, there are also lab aprons when you first come in the door on the right. Okay, so if you want to wear a lab apron, you may also do that. Okay, that's entirely up to you. Just make sure, guys, again, that you're not wearing flip-flops or open-toed shoes tomorrow in case anything spills off the edge. It could land on your unprotected foot. Okay, better to sacrifice your shoe than your skin. Okay, when you go in there and you've done that, okay, then you're going to come up to the front, and on a silver cart will be the equipment you need. One of those pieces of equipment will be this thing, right? This is a depression plate. It's not sad. It won't make you sad, okay? It's called that because it has depressions in it, okay? This is where you're going to put the unknown samples. But you're going to need to label this with a marker. So I'll have some permanent markers there, okay, that you can write like A, B, C beside the depression, so you know which unknown is going in which pit. Okay, so you put a little bit of each thing in there. Now, when I say a little bit, we said it has to be the same amount. We don't have time to measure in grams and make sure we got exactly the same amount of everything. Okay, it just takes too long. So what we're going to do is we're going to say you will fill the depression to about 1/3 of the way full. You might want to make a quick note of that. Okay? In your procedure, you want to tell them, okay, fill it 1/3 of the way full with the unknown material. Right? Then you will take this with all the samples in it back to your lab station, okay? Because people, like, they'll start putting stuff in and they'll start doing the lab up at the front, and then they're just in the way for everybody else when they're trying to come up and get their stuff, okay? There should really only be one member of your group that comes up to actually get everything. Okay? Otherwise, it gets way too crowded. So you take this back, and now you can start performing the observable properties test on each of the unknown materials. Right? So things that we will want to observe. Okay? And this is something you'll want to put in your procedure. What do I want to observe? I want to observe things like and record color. Okay? State. Is it solid, liquid, or gas? What's the nature of it? Is it crystalline? Is it waxy? Is it cloudy? If it's a solution, is it cloudy? Okay, what does it look like? All right. Probably want to do an odor test, okay, as part of our observable properties. See if any of them smell. Now, here's the problem with the wafting test on this. Waft, what do you smell? All of them, right? That's no good. All right. So what you want to do is to do the wafting test, send one group member who's not congested or has a cold, okay, up to the front, because I've seen that happen. And actually, the person sneezed into one of the samples. Don't send the person who's congested to the front. Okay. So send a person up there, and they can just quickly waft each of the unknown samples in its large container. Okay. You don't want to do the wafting test on this. It just doesn't work. All right, so you got to find a way to kind of write that out, okay, in a nice procedural form with your group. Okay, and it's okay, guys, if as a group you got one person when I put you together with your group, which will be in a few minutes. Okay, if you want to have one person kind of type that all out, and then each of you can copy the procedure part. That part I'm okay with, but each person should have kind of their own hypothesis, their own variables, okay, things like that. I didn't mention this before, but if I get 2 lab reports that are identical, you both get 0. Okay, these have to be done independently. I understand some things will be similar, some things will be the same, but the whole report should not be a carbon copy. Okay, everybody does this on their own. All right, so once we've done the observable properties, okay, we said that the next thing that we want to do is a solubility test. Oh, and I forgot to get, there's little wash bottles, they're little squeeze bottles, okay? They'll be filled with distilled water. That's what you will use as your water supply. Do not use tap water. That's probably something you'll want to make a note of possibly to put in your procedure. Okay, so the solubility test, okay, we want to observe for dissolving. You might want to tell them what kind of signs that would be. Look for the liquid to assume the color of the crystals, or for the crystals to change shape or disappear entirely. Okay, and you want to use this highly technical device. It's a thermometer. You probably call it a thermometer, okay? But it helps us to measure the kinetic thermal energy of a substance, hence thermometer, okay? So we're going to use that. That's going to be in the testing material while the water's being added, etc. We already talked a little bit about that already, okay? So you'll be using that during this test, and you'll want to watch for any kind of temperature changes, color changes, or any odors that weren't present before. Okay, once you have done that, now you will have solutions that you will want to check the conductivity of. Okay, so your next test will be your conductivity test. Okay, these are our conductivity apparatus. Okay, they have a 9-volt battery on the top and the screen that goes from 1 to 10 on the front. All right, when you press the button here on the side, it lets you know whether they're working or not. Okay, so if the little on light doesn't come on, come get a different one. Okay, or I'll get you a new battery or something like that. Okay, so you press that and then you put it into the solution, and then it'll tell you how conductive it is. Let's say anything 7 or higher is highly conductive, and as a result, indicative of what kind of compound? Ion. Okay, I would say anything like 4 or below would be considered poor conductor or non-conductive. You will actually get some that all you'll see on is the on light. Okay, they'll be that non-conductive. Okay, there really should be nothing in the middle. Right, it'll be pretty obvious whether it's ionic or molecular with that test. What do you need to do with this apparatus and this apparatus? Clean them between each trial with distilled water. So with the wash bottle in the sink, okay? Put them all in the sink and rinse them in there. Don't rinse them up here, because then people get squirted. And if there's anything on here, it gets in their eye, and then there's tears. And I have to ram somebody's face into the eye wash station, which is not fun. Okay, so let's not do that. All right. Once we've done the conductivity test, I forgot to put that down. Okay, look for the lights. Okay, rinse in between. Obviously, yours need to be way more specific than this. This is the jot note version. The last test is the pH test. Okay, so we have these Hydrion test papers. On the outside of the Hydrion case is the color code. Right, so you may want to mention something about that, how they can tell what the pH is. Okay, compare it to the color chart on the case. Right, so you unscrew the lid. There's your pH strips. Right, they start out orange, but obviously when you put them in different things, they will change color. You don't need a full strip for each material. In fact, one strip should be able to test 2 for sure materials. Okay, put it in and check it immediately. Okay, the longer you wait, the more chance that the color will change to something else. So put it in and compare it immediately, and then throw this away. Okay, once it's used. Any unused ones obviously go back in the case. All right, that's how that procedure will work. Okay, so like I say, you guys can decide on your groups. Okay, just make sure that everybody's got a group, everybody's included. Okay, if you see someone who's not included, make sure you invite them to your group. Okay, so let's say groups of 4. All right, that's a good size because there's 4 places kind of around each lab station. So if we can go with groups of 4, if we have to have a group of 3 here or there, that's fine. Okay, but let's go with that for now. And I'll let you guys kind of sit. You guys can move around if you need to sit with your group, come up with your procedure, how you're going to word it, okay, that kind of stuff. If you want to compare how you did your variables and your hypothesis, I'm okay with that as well. Okay, what you guys need to have ready for tomorrow is the following. Okay, and you have to have a paper copy of the observations chart. Okay, so it's in your lab report here, but you can't take the Chromebooks across the hall into the lab. So you need to have a paper copy of this. You don't necessarily have to print it. You could just make a hand-drawn version of it real quick, but make sure you leave enough room to write everything you're going to need. Right? Then transfer it into here, into this report after. Okay? You're going to have that. and your procedure ready. Okay, you'll probably want to have your procedure you can always look up on your phone, right? I mean, for all intents and purposes, you could also edit this on your phone. If you have Google Docs on your phone, you could start typing in your observations on your phone in the lab if you wanted to, but caution, there's water in the lab, right? And we don't want to get anybody's phone to take a bath. Okay, so keep that in mind. It's up to you. Have a paper copy or have it on your phone. That's entirely up to you, but the Chromebooks won't be going across the hall. So have the procedure ready and the observations chart ready. Okay, it should realistically, if you do a good job of having a detailed procedure, it should take you and your group the remainder of class to have those things ready. Okay, so you should have basically the first half of this report ready to go. Right, the rest of the report we won't be able to do until obviously we have our observations. Okay, the rest of the report is basically this chart, and that is filling it in. So was substance A ionic or molecular, and what was its identity? Right, that you won't be able to do till we have our observations. Once you've done that, then you'll have your conclusion. Remember that in your conclusion, you copy and paste your hypothesis down here, and then you use your observations and what went on in the lab to accept or reject it and explain. Okay, and then lastly is your evaluation, where you will identify any sources of error in the lab and explain how you could eliminate them to improve the lab. There's class discussion questions underneath there. Don't do those. Right? That's what we talk about after I've marked your lab and given it back to you and we've gone through it together. Then I talk about the class discussion questions at that point. Right? You can look at them if you want, okay? But you do not need to do them beforehand. Okay, are there any questions before I set you guys to work? Okay, I've made the due date for this. I think I made it Tuesday, not tomorrow, next Tuesday. So you have a full week, okay, to work on it. Come in and see me for help if you have questions. Talk to your group members, figure things out. Normally, I don't give a full week for a lab report. This is your first one, so I'm giving you lots of time. Okay. All right. So get together with a group. Remember, groups of 4. Okay, if we can make it that way, and let's get going on getting procedures written out.